Hello, Truncail here for Modern Physics Lab. I'm going to give you an introduction to the looking at light experiment. Now this is one of two experiments that we have in our Modern Lab sequence that's a survey of mini experiments. All right. One of the main goals of this experiment is to try to figure out where light comes from different objects. So we're going to have a bunch of different sources. We're going to have lasers. Rajeet, if you want to go over here, we're going to have a bunch of gas discharge tubes. All right, so these tubes are filled with a gas. We're going to go ahead and send an electric current through them. So we're going to, if I can actually just flip one on so you can see what I'm talking about. You can see that it emits light. All right, so for this particular tube, we're going to try to see, all right, what is that light composed out of? Meaning, you know, is it just red? Is it just orange? Is it a combination of a bunch of different lights? And then how does that light actually get emitted from that gas? Now, I'll point to one thing on these gas discharge tubes. You're not going to want to go ahead and turn these on and then really touch anything. Once you turn the switch on, leave it on while you collect the data, but then also you're going to want to make sure to turn them off. They're not lamps. These tubes do have a life to them, and it's not a whole lot of hours. So as soon as you're done using any of the gas discharge tubes, make sure you just turn them off when you're ready to go. So if you come over here, we're going to be using a program called SpectraSuite, which connects to an oceanoptic spectrometer. All right. So the business end of the spectrometer, if you want to point it at me, Majid, is this piece here. All right. There's a little opening at the tip of this. All right. You're going to want to point this at your sources, and that light's going to be connected or collected and sent through this fiber optic to basically diffraction grating, which is going to split that light, and then the computer software is going to show us what that light's composed out of. So here's what I'm going to do. When there's no light going in here, once you set this up, which the instructions very clearly show you how to do, you're going to be able to see the visible spectrum here. So Majid, while you look at the screen here with the camera, I'm just going to point the fiber optic to the fluorescent lights in the room. So you're going to see we're going to get a signal once this spectrometer gets light. All right, so that's going to be the main way to collect data. You're going to point this at something, and then you're going to use a bunch of these toolbar buttons here to collect data. All right, Dr. Mulhall is also in the room if you want to go ahead and turn the lights off and come on over. He's going to help us demo a few other things. So we're going to show you a couple things. So I have a green laser here. Right, so this is a pretty powerful green laser. You're going to want to make sure not to, point it at your own eyes, and you're also not going to want to point the laser light directly into the spectrometer. So if I'm over here at the table and I turn the laser on, right, you're going to want to point the end of the fiber optic at the reflection of the laser. And you're going to see from on the software that even the reflection is pretty intense. All right, so you can see this is effectively, one wavelength of green light, but you'll actually investigate what the resolution is of the spectrometer. That's one of the mini experiments, okay? So here's a basic question that we're hoping you're going to answer at some point. So my shirt is blue. I hope it's coming up that way on the video, all right? So you might think that this is blue because my shirt is absorbing all the other colors and it's only reflecting blue. Well, then answer this question. If this laser, right, is only producing green light, how come when I do this, that green light isn't actually absorbed? So this is one thing that we're hoping you're going to be able to answer by the end of this. Here's another cool thing that we're going to be able to answer. So Dr. Mulhall is going to control the spectrometer, right? So we have this salmon, pink colored piece of paper or whatever it is. So you see that this is only green light that I'm emitting from my laser. What's going on now when I move that green light onto this salmon colored piece of paper? It looks like we get some crazy yellow color. So look at the spectrum now on the screen. We have that same green light, but then we're getting this funky shaped yellow-red emission that we're picking up, all right? So this is an example of fluorescence. So you're going to experiment with fluorescence a lot in this experiment. There's one more cool thing that we're going to show you in this video, not to give away the entire store. So what Dr. Mulhall has in this little bag, and by the way, all the supplies for this experiment will be located here in this drawer, all right? Including this thing that's in this bag. Now what's in this bag is a very small sphere, and it's essentially lab-created ruby. So you might think ruby, gemstone, probably expensive. Yeah, it's pretty expensive. We're not going to want you to lose this little red sphere, or Dr. Mulhall is going to come after you. So watch what happens. Yeah, there you go. So watch what happens when I shine this same green laser light onto this ruby. All right, and then Dr. Mulhall is going to pick this red. Ooh, that's so cool when it changes from green to yellow there. All right, so now when I get to that ruby, whoa. Let me see if I can hold my hand. That's really, look at that.
Look at that.
Look at that. And look at the really big red peak. So you notice, look at the spectrum. Look at the spectrum on the screen. We're hardly seeing any green at all. There's a couple little reflections that we're picking up, but look at the giant red emission that we're getting from that ruby when we put the green laser light on it. Another example of fluorescence that you're going to explore in this experiment. Okay? All right, that's going to be the end of the video. I also just want to let you know that the instructions are pretty specific for this lab. We hope not to have to interact with you as much, as some other experiments in the modern physics lab. But if you do have a few questions, let us know. But really, just try to read the procedure line by line. It should take you through the rest of the experiment with no problem. All right, see you later.